All right, so this is going to be the review for the test in linear systems here. So all the different types of things you need to be able to do. All right, so let's get a linear system. Again, this review is not for every single problem, but just some of the problems that I figured you might want to know how to do. Like I won't do a Gaussian elimination on here, but you obviously need to be able to do that. All right, so solving a system here, linear system of inequalities. So you're going to graph this and we're going to test the points. So let's do this here. 5 is the first one, 5 is the y-intercept, 1, 2, 3, 4, 5. Put your dot. Up 2 and over 3 is your slope. The question then becomes, is it open, is it a dotted line or full line? And since this is non-inclusive, there's no line underneath, it's a dotted line. And you can read it when it's in this form, when it's in y-intercept form. You can read it and trust it. That means that we're looking at the greater side of this. And then the other one is in standard form. I intentionally chose this one. So you can solve for y. If you're dividing by a negative, if you solve for y, you'll flip the inequality. So if you do that, you'll end up getting y is less than or equal to, and you'll end up getting positive 4x because negative divided by negative, minus 8. That's cool if you want to do it that way, or you can test the point. So this one here, negative 8 is your y-intercept, up 4 and over 1. Or we can test it. We can create our little table here. So 0 in for x, 0 for y. So if I put 0 in for x, that's going to be gone. And so that gives you negative 8, because negative y equals 8. So negative 8. If I put 0 in for y, and that's gone, 4x equals 8. So 4 times 2 is 8. So that's 2. And so 2, 0, and negative 8, 0, negative 8. This one is inclusive. There's a line underneath, so it's a full line. And now I'm going to test a point. So I'm going to test 0, 0 here. So if I put 0 for here and 0 for here, is 0 plus 0 greater than 8? The answer is no. So that's not a solution. So it's on the other side of the line. And so if we were looking at this, it's where they overlap. So it's this part right here. So if I erase all that out of there, make it a little prettier, it's just that part of the region. That's our answer. Okay? You definitely need to be able to solve via substitution, elimination. You'll be asked to do that. And that I'm going to skip over on here. But I'm going to go ahead and do one for Cramer's rule. So we have to be able to solve a system using Cramer's rule. Again, substitution elimination, go back and watch a video on that if you need to. But you should be confident in that. But Cramer's rule, something a little different. First off, Cramer's rule, it must be stacked up. So I'm going to make this problem, just making it up as I go here. And I could use elimination, but except I told you that we're going to use Cramer's rule. So you set your matrix up using the coefficients. So this would be considered A, using the coefficients here. So it's 3, negative 1, 1, 2. So that's matrix A. So I find the determinant of matrix A. So that's 6 minus and negative 1. So mind your negatives. So that's 7. And then matrix A subscript X, the X's are replaced with the solution. So now instead of 3, 1, I've got 12, 3 there. The Y's are still the same. Find the determinant just like the other one. So 24 minus negative 3, so that's going to be 27. And then do the same thing for Y. So the X's are back to the same. And now the Y's are changed with 12 and 3. So that's 9 minus 12, which is 3. Again, so determinant here, so 9. 3 times 3 is 9. 1 times 12 is 12. So 9 minus 12, which gives you negative 3. So then our solution is X is 27 sevenths. We're dividing those, and Y is negative 3 sevenths. That's your solution. And you could do that elimination, but I'm going to ask you for Cramer's rule. The thing that's new to this chapter is the area of a triangle. So you have 3 vertices, and you're going to go ahead and any three vertices. We're going to find the area of this triangle. So if you have some triangle and we've got some area, we're trying to find out how much it is there. So we're going to set this up into a matrix. 3, 5, 1, 2, 10, 1, 6, 4, 1. So the one thing that's interesting about this is that you have to have ones in the last column. And we're going to do the matrix in our calculator and go to determinant. And remember, it's 1/2, whatever that value is. And if it's negative, we'll make it positive because it's the absolute value actually. So I'll check that in my calculator. Negative 14 in your calculator, and then you take 1/2 of that. So that's going to be negative 7, but I said absolute value, 7 is our area. So it's actually a nice whole number, believe it or not. So pretty neat that that works. So that's one of those things that you haven't done before. Give me an equation with a solution that is like 2, 6. So you get to make up your own equation. So you can choose whatever you want to do. You can make it as painful as you want on me. So you get to choose, set your equation up, and then it has to be a true statement. So this is just sort of a little bit higher level question. So this is going to be 4 times 2 is 8, 5 times 6 is 30, so 38. And then let's say negative 3x plus y. So negative 3 times 2 is negative 6. 6 for y, that gives you 0. So this would be the equation. Or you can choose someone else. You can choose any values for this, and then they just have to work. So this is a very open-ended question. You got to be able to do one on your own. So yes, so you choose whatever you want to do, and I just have to check every one, which is really annoying, but good for you. Okay, some sort of story problems. You're going to have 2 types of story problems, or three types. So if you have a slope in a beginning value, that's the y equals mx plus b. And if you have a known total, if it's a known total, that's the ax plus by equals c. So you have to, that's of course when you have 2 unknowns. If there's 3 unknowns, like when we did in 1.4, then you would have 3 variables there. All right, so give an example. So say Johnny has got a business here. He's buying something and he's going to sell something. All right, so Johnny, he's making his own hats. He's got it for his website that he's got, so Johnny, it's cost him, let's say $300 to design everything and get everything going. Each hat costs him $10 per hat. However, he sells them for $25. So revenue there. So we've got 2 equations. We've got the revenue, $25 per hat. There's no beginning value. There's no beginning revenue. He hasn't been gifted anything in terms of money there. The cost, $10 per hat. So that's a variable. But he has an initial cost of $300, maybe whatever the design software is or something like that. And so now we have our equation, and we've got to figure out when they're equal. So you can make a table to make them equal. You could graph them to make them equals, and you could do that on a calculator. You can solve this as an equation, which is probably the easiest way. So 25x equals 10x plus 300. If you solve, you get 15x is 300. And so then 15 goes into 300 times. So x is 20. So at 20 hats, he breaks even. So Johnny takes him 20 hats to sell. So that means that it's not a whole lot of overhead, meaning that 300, get it overhead? I didn't mean that, but $300 initially, and eventually he sells more and makes more. So at this point is 20 hats. At 20 hats, he is broken even. After 20 hats, he's making money. The other standard story problem would be like adults and students going to a game. So the adults cost, let's make them $10. Students, $5. $5. And they have a total of 450 people that went to the game. Okay, 450 people went to the game, and the revenue was $3,625. And so we need to write an equation. So you got two variables, so we have two unknowns, so we have two equations. So the first one, we got 10x, or we have 10x, or 10a, doesn't matter what you want to use here, and 5y, so x is adults, y is students. And there's a total of $3,625 because we are looking at cost per person. So if there's 20 adults, it's 10 times 20, that's $200. And then the hidden one is that x plus y, if you add those together, it's 450. And so the big thing here is that we can go ahead and just RREF this thing, and unless I've screwed up, it's 275, it's 175 on that. All right, good luck.